So this is kind of more of an open, like you guys are coming back together, doing that data exploration. Hopefully you guys had some fun doing that. I know like some people already mentioned screen sharing was disabled, so I'll make sure to enable that for next time. I'll change that in the setting. But yeah, so first of all, does anyone want to volunteer like anything interesting they found in dataset? There's nothing interesting about that data at all. Huh?
Yeah, I'll go.
Okay, who's that, Simon?
Yeah.
Yeah, go ahead.
Well, it looks like women tends to do more walking than men.
So more steps, right?
Yeah, more steps. However, the average count or average steps is more for men though. So even though they like to do more walk, but they probably do shorter distances or something like that.
Okay. So maybe there's something going on there. And then I think someone, Clark, did you have something to add to that?
No, I mean, just it's nature that to see that the women are, I mean, for the most part, women tend to have higher BMI on average, I think, in the population anyway. So was unsurprising.
So it seemed unsurprising, seemed kind of close. Yeah, we haven't done any hypothesis testing where we could formalize this, but yeah, cool. Anything else? Anything at all? Anyone found interesting?
And then the BMI for the women seems to be bimodal.
Bimodal? Okay, interesting. Okay, so it seems like there's two different peaks going on there for the BMI at least. Awesome. No, that's great. So there's actually one particular thing I'm wondering if you guys have found about this data set. I'm wondering if you know what I'm talking about, like speak up now. And it's very different from most data sets. Very, very different.
They can be merged.
Yeah,
so they could be merged. It's if anyone's merged them that you could do that for sure.
Okay, so I found something really strange.
Yeah, what did you find, Safe?
It's a goddamn ape.
Yeah, there seems to be a gorilla. It's actually a gorilla in the data set. So some people right now be like, what's going on? If your group kind of went through that, you might have figured something out. But let me go ahead and share my screen and I'll show you guys probably what Safe noticed. So you guys have the visualization. You guys can see the notebook right here, right? Visualization. We load the data in here, all that good stuff. And just the head and stuff like that. And you can do all the different statistics and stuff. But the one particular one I'm looking at is actually, I'm going to plot out. I'm going to combine both of them together. But it does exist in both data sets. And I run this guy. That's your data set right there. So this is actually a really interesting one. First of all, it's a good practice just to kind of like play with data and see what's in there. But this is the kind of thing why data visualization is going to be super important. This is actually done in a study. So I can actually let me go to the README right here that I created. It's actually from this paper right here, where they gave, if I remember right, they gave statistics students to look and to see if they could, they told the students, okay, here's the data set, find a few hypotheses, see if these are significant. And what they really did was just basically have a gorilla in there. And this kind of motivated, if you guys ever seen like the basketball being passed back and forth, and there's a gorilla that walks by, and like people are told, count the number of basketballs that are being passed back and forth, or number of passes, and it turns out there's actually just a gorilla there, and that's the real experiment. That was kind of the motivation here. So this is actually in the README in the data set. I actually saw this a while ago. I think it was earlier this year, this tweet, whatever. Let's see if I can actually go to it real quick, just to give its reference. But I think it shows a little bit of like how important, oops, that's the wrong one. Sorry, I'm just trying to get the tweet itself. It's on the HTML, so I'm trying to figure out which embedded part. There it is. Okay, so you guys can see a little bit. This is actually one of the authors of that paper. But you can see how important, like their point of their paper is like, if people are really focused on the hypothesis and what hypothesis they're looking for, they'll miss really obvious points of the data. In this case, literally, if you plotted out the data points, you would see that it is in fact a little gorilla waving high. So that's kind of our motivation, a little trick for you guys, also practice. But why visualization? Like we are really good at finding patterns. And as humans, we tend to be really good visually at finding patterns, sometimes to the point where we might find patterns that don't actually exist. But just kind of know is that going into these kind of things is that you want to make sure that you take that time to say, okay, let me just look at this basic data. Because I gotta say, we'll see a little bit, but numbers usually don't do enough justice by itself. Okay, so that moves us into our little motivation notebook. So I'm gonna kind of motivate it a little bit further, like why visualization? So you know, visualization, you think of like writing these graphs, these plots and things like this. I just loved it. There's a little clip from How I Met Your Mother. I don't know if anyone's familiar with that show. It's not on the air, or you know, ended their series already. Where Marshall, one of the characters, just loves graphs and different visualizations. So there's a favorite, his pie chart of his favorite bars, and of course, you know, bar chart of his favorite pies. You know, so like I would think in another life, he's supposed to be a lawyer in the show, but I think some level he probably would be a data scientist. So the real question is like, why do I care about data visualizations? I think sometimes in data science, people tend to put them on the lower bar of like things to care about. And why is it actually important? So the first thing you should care about, like why you should care, is that your goal is to tell a narrative, tell a story, tell a narrative with your data, because the data are going to be the facts, right? Of at least, you know, like the data are the data. That's usually kind of the phrase. But that data can be interpreted in different ways. And your job as a data scientist is to say, why is this data, why are these data relevant to the stakeholders? And what does it mean for us? And that's actually not an easy question to do. And a lot of times you're going to also be talking with people who are not data scientists and being able to say like, hey, this is what you should do based on the data, and being able to present that in a good way. So you can think of it like data visualization as part of your story narrative. You'll hear me say narrative a lot when I talk about data science. A picture is worth 1,000 words. You can immediately look at a visualization, a good visualization, and see immediately like what you should be focusing on. So visualizations are really useful in like finding like, you know, patterns and stuff like this. Like we can see very immediately this blue, you don't even have to know what it is. You're just like, oh, the blue bar is higher, right? You can see that almost immediately. So that's kind of what the idea of a visualization is doing, is emphasizing points that you can do numerically, if that makes sense. And the last one is numbers are awful to look at. So this is kind of related a little bit. This was a different warm up I had with other students and stuff like that, but I wanted to show you guys this. Is that let's take some data right here, and I have some data points in here. I'm going to import pandas, matplotlib, and then you can see this df1. Like it's only 10 data points. Just looking at this data, can anyone see anything? Like, does anyone know what that means or anything like that? I don't know. Like I'm like, I look at these points. I'm like, I can see generally, and I can maybe calculate a few things. So I can do like, you know, df1 describe, and I can see a little bit like, oh, the count, you know, there's 11 points. You can see that the mean is 9. For X, the mean is 7.5 for Y. You can see standard deviations, right? All that good stuff. We can even see the median right here. But like I don't know, like that doesn't, nothing says anything special, at least looking at this data. However, if you visualize this, we can see it's like, oh, okay, like we can see there's a definite, like we can see that pattern almost immediately, right? Like you can see they generally trend as X goes higher, Y goes higher too, where this is just 10 data points, but imagine having many, many data points going through, okay? So let's go check out some other stuff too, right? So it's about the distribution. So what about this distribution? So we have a different data set right here. It is different. It is also going to be 11 data points, I should say. And guess what? The mean is about the same, 9 for X, 7.5 for Y, and you can see a little bit. If I can kind of minimize this a little bit, is you can kind of see there's 7.5. So you can see the mean's pretty close. Standard deviations also, if you look at it, pretty close together, if not exactly the same. See, it's a little bit further off, about the same. And you can see actually the mean is a little bit, or no, the median's a little bit different, but not too far off. Okay, so you're like, okay, like anything special about this one? Probably not, right? Well, if you look at it now, you can actually see that this has a very specific pattern, very different from the other one. I mean, I should say there's some similarities, but this is like, if you look at this data, you're like, oh, this is very like controlled in the sense that it's a quadratic formula or quadratic relationship. Okay, so this is kind of the idea. Is like we can look at two things, even though this stuff looks very similar. Most people can't look at this plus this and immediately know what the pattern is already. And that's where visualization really comes in. And let's just do one more. So there's a secret data set right here. And this one's a little bit larger. This one's actually let's see, about 142 different points. So like I won't even bother you guys looking at this, but 142 points. You can't even look at like 11 and like know exactly what's going on. And if you actually check this out, there's a dinosaur. So in fact, this is actually a very special data set. This is the data source Rex. And there's actually a great paper from Autodesk that actually showed that they can show that all of these different distributions that you're seeing right now flashing through this animation have almost exactly the same mean for X, Y, standard deviation for X and Y, and correlation, Pearson's correlation factor. And you can see these values right here are just slightly changing. And this kind of shows the point of that, like, remember that when we do statistics, especially these summary statistics, it is a summary of the data. It is not the full data set itself. And reality is, like, you can't look at 145 different data points, if not right, millions of data points. We can't even look at 10 and really understand what's going on just by the numbers. Us as a human, our human brain has been kind of really good at looking at visualizations and finding those patterns. And so that's why visualization can be super important, not just for presenting information to other people, but also essentially presenting information to ourselves. Okay, cool. Any questions, any comments? No? Cool. Yeah, this is a great little paper right here, but this animation is just perfect. This actually kind of goes off of, for the record, these data sets come from Ascom's quartet, which I think is actually referenced in here. Let me just kind of pull that up just to show you guys what it is. It's a very famous set. There's Ascom's quartet. I don't actually know if I pronounced that correctly, but you can see here, these are actually the data points, and you can see these actually have almost identical mean variance for X and Y and correlation factor as well. And they're very different from each other. So that's kind of an importance of, like, actually investigating these different data points, or sorry, visualizing these different data points. Okay, cool. All right, so let me move on then to our next little notebook. Like, okay, like, what are different visualizations and how do we use them? So there's really two ways to use visualizations in data science, and I would say in general. But the first one for data science is really about exploratory. So we do it for ourselves. So what we're doing here is we're searching for insights that we're looking for insights. So it doesn't have to be super polished, it doesn't have to be super neat. It just has to give us like a quick, dirty, like let me just take a peek of what this data looks like. And you're using this plot to basically look for patterns, try to answer some questions that you already have about data, and maybe even things to explore. So for example, I kind of pulled up Ascom's quartet. You might, for example, if you had this data set, and you see this one point over here, you're like, hey, what's up with that one data point over there? Let me go investigate that. So like the idea there is to find those patterns and see, what things might be interesting to investigate, or if there's an answer to a question that you started asking. Okay, things to note for exploratory visualizations: they don't have to be perfect. You're looking for patterns and relationships, and they usually connect to some question, whether that's creating a new question or there's a question that you already have from your stakeholders or things that you know as a data scientist. Okay, makes sense there, people? Yeah. Any questions or no? Cool. All right. So this is usually done early on, but you can do this throughout your whole process. But think of like data exploration. The next one is explanatory. Explanatory is really doing it for them. So what I mean is that you're basically highlighting messages, or not messages, insights to other people. So usually I like to say, it's like, this is kind of closer to like when you're doing a presentation, but this can also be to other data scientists, not just non-technical people. Usually you should be careful, make sure they're actually insightful, they connect to the question or the problem that you're asking. They should be insightful, accurate, visually appealing. Visually appealing, one is like, yeah, you want to make it nice enough to look at. You don't want crazy colors that kind of strain your eyes, but also visually appealing also comes with the fact that like you should make sure that it's accessible to other people, right? So making sure about like colorblindness and such can be a huge factor. So things to remember is that for explanatory, is that you're highlighting an insight. It's kind of surrounded by a story. So you point your readers to an answer. An explanatory visualization isn't like the answer. You can say, oh, and here's a visualization, especially to non-technical stakeholders. You want to say, here, like, this is the question we're asking. We look at this data or this visualization, and we can see these are the things that we're like, it's like, oh, this is the pattern that we notice. So you want to always tie a story to it. And then you can simplify, note that like explanatory doesn't have to be completely precise, mean that you show every single aspect of the visualization, because that can actually be more confusing. You just want to make sure that you're telling an accurate story, and you might simplify it and say, okay, let me not include every data point. So for example, let's say you do some analysis and you find, just to go back to an example, we see these data points. It might not be super important to show every single data point on like the scatter plot, but maybe the line the regression line that's for those points, that might be the important thing to actually show. So know that you can simplify that. Just be careful you don't simplify too much. Otherwise, you might actually mislead someone or even mislead yourself. Okay. Sound pretty good? Yeah. All right. Feel free to interrupt me with any questions at all. All right. So when to use these, right? So you can kind of think about like when we have like the different parts where we're extracting data, acquiring data, we're cleaning data, we're exploring data, analyzing and sharing, right? You can kind of think of where these exist. So extracting data, usually we're just getting the data itself. When we're cleaning it, well, we're probably using exploratory visuals, right? So we're looking to see like what patterns can we find in these visualization, or sorry, in the data, and we can do that through visualizations. This isn't going to immediately tell you everything about it, but it can give you some hints too. There are some very obvious things that you can look at. For example, if there's a gorilla living in your data. Other things, exploring, right? Your explorations. Like I always think of the cleaning and exploring data kind of very similar to each other, because usually you have to explore it or to know how to clean it. So again, you would use more exploratory visualizations. And then analyze, when you do that actual analysis, like whether that's hypothesis testing or predictive modeling, you might be using a mixture of exploratory, kind of seeing what's going on, and also explanatory. So maybe as you do things like let's create new features, you might explore them and kind of check if that makes sense. But you also might do explanatory, saying, oh, let me see, like kind of solidify the answer to this question, you know, saying, oh, like this does make sense from what I am like summarizing, and making sure those visualizations emphasize those points. So that's where you get explanatory visualizations. And of course, when you're sharing, you can probably guess most of the visualizations, if not all the visualizations you show, share like to especially non-technical stakeholders, are going to be explanatory. Very rarely you would show exploratory unless you want to really emphasize saying, oh, like there's this really interesting part that we found in our process, and I wanted to show you that. So most part, we're going to do explanatory visualizations at that later stage. Okay. Cool. Any questions? Kind of just kind of run right through this. Hopefully you guys are getting it. Good. All right. I'm not going to go through whole quiz time and stuff like that. I think you guys can pretty much kind of figure out a little bit, like, is it explanatory or exploratory? So we won't go through all that stuff. Okay. Some more practice, just kind of another resource, and I'll put this in the chat right now. Just copy the link address. So there is, sorry, I got to find my chat. There we go. Here is another resource, Kaggle. Some people I think already mentioned about Kaggle. There's actually a little bit of a lesson here for visualization. So if you want a little bit extra practice, this will take you maybe like, you know, an hour, maybe 2 hours at most to kind of go through. This is more like supplement material if you wanted to get some more practice in visualizations. Another one that I've already referenced before is the Python Data Science Handbook. They have a great chapter, and not so much about how visualizations, like good ways to make good visualizations, but more like the technical part of like using Matplotlib and Seaborn and stuff like this. I actually think this is a great resource. I personally use it like all the time. Like I like will forget how to do something, and I will literally go like search this book online just to make sure, or like, you know, say, oh, how do I do a subplot? Subplots always break my brain for some reason, but you can always go back to this thing. So it's a really great resource too. Okay. Cool. All right. So we're going to move right along to my favorite stuff. So this is going to be how to make good visualizations. So note that like I'm focusing away from that code because if anyone who's like, give me a thought, like kind of give me like a rating on how you guys feel about doing Matplotlib right now. Like we're like, oh, I'm a Matplotlib, like maybe not master, but like I feel pretty comfortable with Matplotlib. I think if it's somebody asked me to make a visualization, I can make it pretty quickly. And give me like a down. It's like I haven't even touched Matplotlib. I don't know what you're talking about. Sideways, like I think I'm getting it, but like I need a lot more practice. And yeah, I see a lot more, like almost everyone's sideways right here. And I will tell you, I'm like maybe at best like this. Like there's like so much in Matplotlib. And I do not claim to be a master and stuff like that. And I will reference my old code and other people's code to see how to do different visualizations because there's a lot out there and such. So the important thing is not so much about how do you make every single plot in Matplotlib. It's much more saying, how do you make good visualizations? Like what can you focus your efforts towards? Like what should you strive to make? I had a student once, you know, really bright student. They like made this great visualization and they were saying like, oh, like in their project, and they were going their assessment. They're like, oh, I really love this visualization, you know. And then they were looking at it and like, wow, that's actually really complicated. Like I was really proud of the code, but I realized this is not a very good visualization. And sometimes that happens at times. So my goal is to kind of teach you what makes a good visualization. Okay. All right, so let's go right into this notebook. visualization DNA. So we want our visualization to convey information via aspects humans can distinguish, right? We basically want our visualization to actually get something useful to people, right? We want to make people can actually read everything through. So some aspects that we want to focus on are things like position, length and size, shape, color, angle. So we'll talk about like what angle is. But these are kind of things that we can do to distinguish different aspects in our data. So position, like this is kind of really obvious, like where the data resides. Like, you know, of course you can look at the specific values where that data resides, but you can kind of see where like, if the data point is over here versus over here, you're going to know like, oh, okay, I need like that's a different data point. So we can use that to make visualizations. Length and size, think of like bar charts, right? So obviously the length of the bar chart, or you can think of the size, but I think that like the length of the bar chart shows, you know, how like this value and stuff like that. Like it's very obvious. Stacked bar charts, if anyone's seen that before, this is also a really common way to kind of like represent saying, oh, how much something's going on here. Note that, you know, this is kind of an interesting one because we can see that, for example, this is US gun manufacturing by 1986 to 2010. You can see the overall gun production, right? Which you can see like, you know, oh, there's a lot more gun production in these years right here than like these years. But you can also see a little bit of, you know, it's a little bit harder to track, so it depends on the situation. But you can see a little bit is that the revolvers seem to have gone down. It's a little bit smaller in these later years here before they kind of stack back up. So you can kind of get a little bit of like I think for the most part, you can look at that and get a general feel without being misguided, where we can see probably like the orange doesn't seem to fluctuate as much, but there does seem to be a little difference. Okay, cool. Yeah, and of course, like I said, shape, you can have a scatter plot where the different data points are actually larger or smaller depending on like some third value. Okay, it's also shape, so we can also distinguish different points with like different shapes. For example, if you have like let's say, you know, men and women, or, you know, some other data points that are different, like in different classes, you might have different shapes for that point. Like usually the classics are dots, squares, triangles, and like stars. Okay. The other one's really obvious often, like people think visualizations as color. So it's really good to use color you can draw specific things. So to draw, how to say this? To draw specific like aspects of your data, your visualization. So I actually do not like how Matplotlib and Seaborn by default will automatically color things super colorful automatically, because like, for example, why is this orange versus blue versus green versus red? Like there's not like they're different things, but we can see by position, this is Thursday, this is Friday, this is Saturday, this is Sunday. What do the colors actually do for us? And in a lot of ways, they don't really do much for us. They just kind of like make things pretty. My preference is actually to make them all the same color. And then you can use color to emphasize a certain like block. For example, you really care about like the weekend and you highlight the weekend a different color. Or it's like, oh, this value is like really weird. Like it's like, oh, this is a huge value, or this is the year that we really want to focus on. You color that with a certain value. So color is really useful in doing that. So you'll see things like in scatter plots, that kind of makes a lot of sense when you have different classes. Bar charts, again, sometimes, I put this sometimes because I don't really like this preference, where we have this, like Seaborn loves to put like a rainbow of colors across the bar chart. But usually the best thing, like in most visualization experts will say, it really is better to make it a uniform color and using a color to stand out a specific point if it really matters. Okay, does that make sense to people? So, you know, awesome. All right, and then angle. So I put angle in here, and I made sure to put don't use this. So for the record, don't use angle, which we'll talk about why pie charts are the worst. Angle is technically something we can use to define what's it called, like different values. People are awful at it. What they find from research is that people just have a hard time distinguishing different angles from each other, especially when they're disconnected from each other. We'll talk about a whole bunch of pie charts in a second, but you can see here a little bit of the angle. So this right here is a classic pie chart with way too many classes in here. And I found this fun monstrosity right here, which is like combining a donut chart. Usually that's what people talk about, donut, and then like a pie chart. And I just don't understand. Like, I'm sorry. You'll see my little preference here. I hate pie charts so much. I don't understand the donut and the pie chart. They're basically doing the same thing, but it makes it a little bit like, it's just a little different and everything like that, because we'll talk about this, but the area doesn't directly define what this value is. And we find that people actually can have a hard time defining it. Has anyone read this section on the curriculum for data visualization by chance? Like kind of scroll through it all? No, you'll see that there was an addition since I last taught it. where they talk about pie charts and say, don't use pie charts. And they show a few examples of why this actually is really bad. Racetrack charts, which thank goodness is not a default like thing you can easily do in Matplotlib and Seaborn, because I guarantee people would love to put this everywhere. But this one gets me. And the reason why, I'm just gonna take a second, is that you can see here, they even put the percentages. I'm very much in the sense like, if you have to put a number next to your visualization, it probably means it's not a very good visualization, because otherwise you wouldn't be able to understand it. But the idea here is like how much of the circle, like going all the way around, like 100% I guess would be all the way around, right? Well, there's some issues with this. So first of all, this, because people are most drawn towards length as like a value, this 81% is the longest one here, right? Which it makes sense. But as we get closer over here, you'll see this blue one actually is a bit longer for this versus whatever this green one is, clothing and music, but they're supposed to be the same value. And you can see it as you get really small here. It's also a small area in like a small like distance, and it just conflicts too much where really all you're supposed to focus on this visualization is like literally like the angle of how far out it goes. Racetrack charts are kind of like pie charts' ugly cousin, and pie charts are pretty ugly already. So from a visualization standpoint, everyone, I'll say, well, we'll talk about pie. As you can see, I have a whole notebook about pie charts, so we'll talk about that in a bit. All right. So like I mentioned a little bit, there has been research done on this about like what visualizations make sense. And basically experts and researchers found like the best visualization patterns are essentially positional changes, so like scatter plots, and length changes, bar charts. But we're really, really bad at understanding certain patterns, such as color hue changes. So everyone loves to do the whole like color, like the US map, and they love to color the chart with like different colors and stuff like that, depending like on the spectrum from like, you know, let's say from like red to blue. And there's like colors even in between there. We find that people actually have a really hard time identifying what exactly is this value supposed to represent. And it's basically reliant on the fact that what other colors are around it, which can actually be really, like not purposely though, but can be really deceiving for what we're trying to focus on the data. Okay. And then area changes. So again, pie charts. Pie charts hate like I have all the bad things in there, other than like they just look very pretty because they're circles, I guess. I don't know. But area changes also are actually a really difficult thing. You'll notice that bar charts technically have an area change, but I would argue that it's mostly length that we're looking at. It's not really the area itself. But if you had like a big like circle versus a smaller circle, like area wise, people get a little confused exactly what they should be looking at. So things to keep in mind. So really, I would say for the most part, focus on scatterplot and bar charts. Those are kind of a great go-to, and you know, they're going to convey the information almost every time. Okay. All right. Any questions? I'm kind of trying to go through this as best I can. I think we still have 30 minutes, so there's plenty of time. All right. So make good visualizations by not making bad ones. So I'm going to show you some bad ones, you know, like clutch your pearls or whatever, you know, like, you know, take a deep breath, and we're going to go right into this horrible world of visualization. So the thing why we should really be careful with bad visualizations is that they can do some really bad things. So at best, they obscure information. At worst, they actually like completely mislead us in a different direction. So one is that they can actually like lie and mislead us, right? Other things, they can hide the data itself. So one thing is that you can basically make visualizations that de-emphasize the actual evidence that would go against your like that would be against your actual like main thesis of like the problem. And then they can also distract, where you can add extra information in there, which then hides, you know, again, extra information. And again, this might not be done on purpose. This happens actually a lot of time by accident, but also there are definitely some groups out there that have purposely done this, and you can see it very obviously and blatantly too. So just kind of be aware of that. So the Bible, like on bad statistics and visualizations, has anyone heard of How to Lie with Statistics? It's a pretty like famous book. No one's heard of this book? Really? Wow. Okay. I usually have a couple of people. I think I saw Eric maybe give a thumbs up. Okay. This is a really great book. It's been written from a while ago, but it's a great book about saying like how to lie with statistics and how people literally lie with statistics and visualizations and stuff. But I think it's also a great book in the sense of making sure you don't do the opposite. Like you don't do those things. Because again, a lot of these cases, I think are just honest mistakes that people didn't mean to necessarily mislead people or mislead themselves, but they ended up having to do that. So especially as a data scientist, when you're looking into this, it's really important that you try to remove that extra thing that can influence you in one direction or another. Okay, so specifically look out for things called chart junk. So chart junk is basically extra stuff. Like I think business people love chart junk because it looks like, ooh, look at this visualization. So chart junks are things like 3D data, extra like heavy lines. I know it's a really small picture here, but you can see a little bit like this one here, like the little cones, and it's 3D and stuff like this. This is extra chart junk. You can see that like people even argue saying that like this extra like these extra lines and values can actually be considered chart junk because maybe it's just too much information and it's just not very digestible immediately. And especially if you're presenting to like something that could be very technical to a non-technical audience, you want to remove those barriers as best you can because you don't want people to remember the wrong thing. I like to tell people is that when you do your presentations to non-technical stakeholders, especially, is you want them when they leave your presentation, if you were to grab them 5 minutes later and say, hey, draw this visualization, what will they draw and what will they focus on? If they're focusing on other parts of it or there's too much information that they miss the main point, then your visualization could have been tweaked a little bit better. You want people to remember the key aspects and the reason why you're showing your visualization. Okay, does that make sense to people? Okay, so Edward Tufts, it's a great kind of like, he calls it like the data ink ratio, is like how much data ink versus everything else. It's like how much of your visualization is dedicated towards, and this is funny because like he wrote this in the days of like you are literally drawing out data visualizations, but like how much is your visualization dedicating towards the actual like data versus, you know, the extra flair and stuff like this. And I say like, you know, part of that flair can also be colors, but you can also see grid lines. Like, do we need a grid line for every two and everything like that? Like, probably not. Again, business people, I think, tend to be going towards this direction, but maybe just because they have a lot of charts to grab. So things to avoid: heavy grid lines, unnecessary text, pictures and surrounding the visual. So sometimes people like to make these visualizations with like these extra like visuals and stuff. Kind of think like infographics sometimes, like they're fun to look at, but like they're not necessarily like supporting just the visualization itself. Shading or 3D components. So like 3D stuff can really be confusing in a lot of different ways. And then like ornamented chart axes and stuff like this. Like I think in the general, if you're trying to present information, you want to make that clear as possible. Now, I will say like you're probably looking at some of these right now and it's like, oh, like I think some of these look kind of nice or like, you know, kind of appealing and stuff. Like, I mean, who likes to look at a good infographic, right? Like I think sometimes that's just fun to look at. And that's something I should let you know is that these are kind of like a little bit my opinions, also, you know, kind of the overall like rule of thumb, but feel free to break, you know, a rule every once in a while too. I don't feel like you have to be strictly put into this part. But just remember your main goal as a data scientist is to communicate information. So if there's something that's hindering that communication, you should probably stop doing that thing. Okay, cool. All right, everyone's pretty quiet, so I'm hoping everything's going through fine. So this is one of my favorite visualizations. Like I'm on the West Coast, so I don't really deal with hurricanes too much, but I am familiar with this visualization. People who are on the East Coast, maybe a little more familiar with visualizations. Just looking at this visualization and seeing this cone right here, this cone with like the white, like, you know, filling inside. How might you interpret this? And you might actually know how to interpret this, but like, what might be your first instinct on how to interpret this?
Hurricanes getting bigger and bigger or something.
Yeah, all right. And yeah, I'm sorry, who said that again? Eric? Okay, thank you, Eric. Yeah, so you can actually kind of, I think there's a lot of people who might think in those terms. And I actually think that's actually, like, when I first look at these, that's what the first thing I think. I'm like, oh, the hurricane's getting bigger. And in my head, that kind of like, I'm not a meteorologist, but I'm like, well, that kind of makes sense. Like, I feel like as the storm goes on, maybe it gets stronger or something like that. But of course, if you guys do know what this is, does anyone know what this actual like filling represents?
Yes, that represents all of the most likely paths. So like if you're like near the end of it on 7 a.m. Tuesday, so like the left end of the cone and the right end of the cone, those would be like all the areas that it could be on Tuesday.
Yeah, this is basically a probability cone. It's essentially saying like how, like if we talk about confidence intervals, we talk about saying like it's a certain confidence interval of how likely the storm will be in this area, or I should say like technically the eye of the storm will be in that area. So the problem is that sometimes this visualization, depending on who's looking at this, might look at like right out here in the state right here, just outside of this cone, like, oh, I'm safe because that's not where the hurricane's going to be, right? And clearly, based on what that is, like, no, that's not how this works. It's not about the size of the hurricane. It's about where the path of the hurricane is, and it can, be on this side right here. There's not a zero probability of it being outside, and that this is not a great visualization for like I would say this is a technical visualization. This is not a great this is not great for people who are not meteorologists or not familiar with this because of this note. You can see here, note the cone contains the probable path of the storm's center and does not show the size of the storm. Hazardous conditions can occur outside the cone. The fact that they have to put this on here like tells you like this is not meant for people who aren't familiar with this visualization, which I call non-technical, people who are not familiar with this. However, if you guys are probably familiar, I'm sure you've seen like news reports and stuff kind of basically show this exact, image, which still drives me crazy. There's a whole bunch of debate I can talk about this, but anyway, I'll kind of move on. So that's kind of a visualization that's a really great visualization, but it's for the wrong audience, depending, or it could be for the wrong audience. Okay, cool. There's something called the lie factor. So this actually comes a lot from how to lie with statistics, is that basically it's that if there's different attributes that are not the main thing that you're getting the data from. So for example, this visualization is a doctor that seems to be shrinking, right? And you can see it goes from 27%, 16% to 12%. If you look at this, it's actually, it's due to the size, like the length of the doctor itself, like how tall the doctor is. That's actually what's supposed to represent, at least I think that's what it is. But what people tend to focus on is actually the volume of the doctor itself. And you can see even the fact that it's like kind of off-centered too. You can't really compare them, height-wise about like how tall they are. It ends up being a little bit hard to misinterpret. And then, I mean, I said it's the length, but maybe it is the area, and it's not super clear exactly what this is representing and value. So that's kind of considered like a high lie factor, where there's another attribute that's conflicting. Area is going to increase differently than length. So that's kind of something to look out. And then this is a really famous one. Again, this sometimes visualizations are done by accident, some of them on purpose. It's debatable. I've heard a lot of debate about this. Back in George W. Bush's tax cuts, you can see here's like 35%. I don't know if you guys can see this pretty well, but 35% versus 2013 was 40%, like 39.6%. But then you can see this huge drastic change, and it's because they started their axis at 34, which, like that is telling, looking at the visualization and not being really like looking carefully at the numbers itself, that can mislead someone to think that like, oh, like the tax cuts, like the tax top rate or the tax rate is so much higher than this one is, where in reality, 4.6%. Well, maybe 4.6% is really high, but like just looking at this, it can be misleading and stuff. So that's where context and making sure that what you're conveying isn't just is not just accurate, but also like conveying the correct information that you want to emphasize. And again, I've seen people redo this literal visualization and saying like, well, maybe that, like, depending if you are for a higher tax rate or for against a higher tax rate, you can kind of spin each side, and they're both factually true. It just depends on how you want to present this information.
I wonder how CNN would have done this one.
Yeah, I think this is where it's one of those things where it's like, it definitely depends. Like again, every like data are not agnostic. Like data like are facts, but by themselves, they don't, without context,
right,
they're just points. So the problem is that like as a data scientist, you have to decide what are the things, how I should interpret this. And that's kind of a classic one right here. So
well, that's the big joke. You can always tell it whatever story you want with statistics.
Yeah, exactly. It really is kind of, and that's not to say something bad about statistics or visualizations or any of this stuff. It's just more the sense that like there is so much dependence on the context itself. Like I always like to tell like I always like hearing statistics like in the news or like reports and stuff like that, or like, you know, even not just news, just like people passing around statistics. And the first thing I always think is like, where's the standard deviation? Like no one ever says anything about like how far away from the mean this happens, because we can have a value, but like if we don't have a standard deviation, like I don't really have a strong context of what that means exactly. So anyway, yeah, so that's where your visualization can be really tough, because this can, like, visualizations, like we talked about, like a presentation, can really stick in people's minds. And if you do it by accident, it might mean that they might now think something different than what you're saying or what you wanted to try to emphasize. So it's important to kind of check yourself in that way. Okay. So 3D visualizations, just don't use 3D visualizations. This is also a famous one. Is anyone familiar with this visualization too? This one's also debated a lot in visualization spheres. So this right here is from Apple, obviously, with, oh my gosh, Steve
Jobs.
Jobs, thank you. Gosh, I was gonna say Tim Cook, and I'm like, no, it's not Tim Cook. Steve Jobs. Obviously, this is when Steve Jobs was still alive. But presenting this information, and you look at this, they have the percents on here. But if you look at this, Apple in green on the bottom here, if you look at that 21.12, I think it's pretty close. But you can see that maybe it's a little bit bigger than it should be. And then you realize like, oh, it's 3D, it's tilted towards you. So since, you know, things are closer to you in 3D, they look bigger. Like that's kind of what's going on here. And again, like, is this something that like Apple did on purpose, you know, like trying to make themselves look like they have a larger market share? Or is it more like, you know, oh, it's an honest mistake? You know, people can debate about the exact motivation of this. But the point is that this visualization can mislead people into thinking that, like, just briefly looking at this, that this green portion of the pie is actually slightly bigger. So things like that. So anyway, and this is why also pie charts are awful, but especially 3D pie charts. Don't use a 3D pie chart. 3D graphs in general are just not great. All right, some tips for color, right? So these are kind of important parts that sometimes people tend to kind of neglect or not think about. But one thing is, for example, like these are actually some really great tips of like actually how to use color. So one is just start with black and white. Just actually like do your visualization. Nowadays, like we actually can like use a computer to like do whatever color you want like instantly. But back before then, like visualizations were all by hand. You would literally, they say like one suggestion is like literally start with black and white. And I think that's still a good rule even today, even if you can put in colors one. Use less intense colors. So not all the colors of the rainbow, like which Seaborn just loves to paint all like every color across like the whole spectrum. It just is easier on the eyes if you use a very small number of colors, not as intense colors. So like neon, stuff like that, unless you really want to draw someone's attention to that. I'm sure you've seen, you know, like visualizations or things like that are really like kind of blinding and kind of like almost feel like they hurt your eyes. So try to do your best to make people not look away from your visualization. Communicate with color. So this is what I kind of mentioned a few times already. Highlight interesting groups with colors. So you can see here they're all the same color, and this might be the group that I really want to pay attention to, and I want my stakeholders to remember that specific data point, right? 1971, because that's what I'm going to talk about. Because then instead of having this whole thing here, and someone has to remember like, what was 1971, what they were talking about? Like, where was that in the bar chart? Was it earlier on over here, over here? You can say, oh yeah, that's right, it was highlighted. They can remember specifically at that point. And I think this is a really great way. And one way you can do that is literally changing the part of the graph. But another way you can do that simply is literally like take your graph, right? It's all the same color, and just like use like an annotation tool to like draw on top of it, like say, oh, here's a circle or whatever, and like highlight it. And I think that's perfectly fine too. So great way to highlight your message. Don't add color for the sake of color. You know, everyone wants to make their things at least a little bit prettier. Maybe I'm a little biased in the sense because coming from physics and math, I was told like you should like have backup transparencies and like, you know, black and white transparencies. So there's a very strong emphasis of like no color anywhere unless you really absolutely need it. But I do think that kind of holds sometimes that sometimes it's too easy to add color and extra embellishment that can kind of subtract. So in general, start off with at least like almost like no color, just black and white. And then really think about, is your color adding to this visualization, or is it really just kind of like making more embellishment, which could take away from your visualization itself. Colorblindness. I don't know if anyone here is colorblind by chance, but I think it's prevalent enough where you shouldn't use, for example, red and green on top of each other. These are bad choices. So this is actually really great kind of like simulation of like what red and green look like to maybe someone who's colorblind, like at least the very different what's it called, how they might perceive like the different view hue. I'm trying to use not color because color is obviously in our head, but basically like how you might perceive something like that's red and green. So never use red and green together, which unfortunately is used like all the time. There's actually full packages though. If anyone's familiar with Tableau, there's actually like packages that specifically use like what's it called? Not for people who are colorblind and stuff. They try to use things that actually can be interpreted for people who aren't colorblind and people who are colorblind. So you can see here is like this hue, this palette right here is a little bit easier to interpret for other people. So you can see the differences, and they're relatively different from each other from what you care about. So just look into that and kind of consider it. Unfortunately, a lot of packages just don't consider this, even though colorblindness is relatively common. It's not like rare. So keep it out there. Cool. All right. Any questions or anything kind of went through right here? I know there's a whole lot and I kind of went through it pretty quickly. But I do take this stuff pretty like you will see, like I am very strongly opinionated about visualizations and how you want to use visualizations. But again, feel free to break rules too. Like, don't feel like it has to be this way, especially doing assessments with me. Don't feel like, oh, Victor's going to fail me on this assessment because, you know, I used a pie chart once. Well, I might consider failing, but definitely, you know, don't feel like you have to fit into like these specific boxes and stuff like, oh, I have to use color and only this way. You might find creative ways to use this stuff. But in general, you want to say, is my visualization conveying information or are attributes subtracting from my visualization? Okay, cool. All right. So we got about 15 minutes left. Just enough time for me to rant about pie charts. Sound good to you guys? All right, cool. Oh, good. I'm glad there's a bunch of thumbs up for me ranting about pie charts. And first of all, let me say, if you have used pie charts in the past, if you have a strong attachment to the pie charts, I apologize in advance, but I'm not really sorry. Pie charts just, there's so much badness. So there's actually like, this is great. I did this, I was talking about pie charts, like visualization, like data visualization, this topic with another cohort once. And literally like that day, like I like on the YouTube channel that I like follow, computer file for the record, talked about doing visualizations. And they said like, literally like this is their whole talk about data visualization, like don't do pie charts. And I just love this grossness of like a nested donut chart with a pie chart and a donut chart without. And it just this kind of gets me a little bit. So it's actually relatively easy to make like, you know, different charts and stuff like this. So here's some data right here. I actually pulled this from the original, like I showed you in the earlier notebooks. You can see a little bit of like what this looks like. It's actually like, you know, like you look at this, like, oh, clearly, you know, the blue, the frontal lobe, whatever this value is supposed to represent, is, you know, the highest point. And then we actually have the orange, green, and then red, different, you know, values. And they go smaller, but you can see these are relatively close together, but they're definitely different. Pie chart can also be done with packages and stuff like that. And you can see clearly the frontal lobe is the largest, but then you can see like this red, green, and orange. You can probably reason, like, I don't know about you all, but I can see that orange and like, oh, it looks a little bit bigger. But it's not really clear like how much bigger orange is from red to green, like how they compare versus a bar chart. I can directly make that comparison. And that's like the first like kind of strike against pie chart. Like, how am I supposed to be able to tell, like, you know, I can't make strong, easy comparisons. And this is where people tell me, Victor, you're being too harsh on pie charts. Pie charts have a place in our heart, just in the right situation. And they'll say, you really should only use it for like, maybe like 3 major attributes that you want to talk about. I'm like, why then do I have to use it if it's only meant for only certain situations? Or they say, oh, like the real problem is that you need to order the pie chart pieces, like in the proper order of like smallest to largest. And I'm like, then why can't I just do that with a bar chart? Because a bar chart, I can immediately see that versus a pie chart's a little harder. So a lot of arguments I hear, I was like, I don't really care for, because I think they're a little bit, they're a little bit of trying to fit things in. I will say is that the biggest plus for pie charts is, for whatever reason, business people just love pie charts. Like, you see pie charts everywhere, and just like, it's just, I don't know what it is. Maybe it's just because it's just like a nice visual thing, but there's just so many attributes of pie charts themselves that just don't the research shows can be very misleading. One thing you might see is people literally have 2 different pie charts and compare them with each other, but then they'll adjust the pie chart size to some value and stuff. And that's probably like I just don't understand. That's like the worst of all worlds. So in that case, you might make more sense to do a stacked bar charts or 2 bar charts next to each other. One other argument, say a pie chart's supposed to be for a whole, so you have 100%, and then you say some portion of that is in a pie chart. Like that makes the most sense for a pie chart. But I would argue is that if you do want to emphasize how much part of a whole, like you could have a bar chart that is a stacked bar chart, but just one line, and you can see that percentage. And what's cool is that kind of like going back to some visualizations that we showed. I want to show you guys this one because I'm talking about it. Where is it? This one right here. This, for example, imagine if like we can see the approximately the proportion of each data point. So for example, 2010, we can see how tall this is and about approximately what proportion is being used, like for rifles, pistols, shotguns, revolvers. But now we can also look, like if you imagine that one line could be a pie chart. But now we can also look at multiple years and compare the multiple years relatively easily without having to like really like, squint our eyes and like to get our rulers out and kind of measure things on the screen or whatever. We can get a general feel for it. If you imagine making each one of those into a pie chart, I would argue it's very difficult to really get a feel for what's going on because the pie charts in general will look very similar. And then I've seen, like I said, people will adjust the size of the pie chart, like the area of the total pie chart, based on like some value, like for example, up to 3 million versus up to like 5.5 million. So again, I'd argue that like a good alternative is a stacked bar chart if you're looking at pie charts. There is another alternative, which is a great blog post from Storytelling with Data. Here you can see some pie charts, and they go into a whole bunch of different extra stuff. So one is just like literally just show the numbers directly, because in the end, that's all that might be the most important part that you really want to show to your stakeholders. Like, hey, this is going to stick in your mind. I literally have had the great presentations, not my own, but other people's presentations, where they've had literally just like 68%. And that's the number they showed. And that sticks out so well because it was literally the only thing on the screen. People remember 68% versus like remembering like what portion of the pie it was. Another one is basically doing like simple bar graphs, as mentioned before. And I think these are good. Now, this is where people might say like, oh, I really want to emphasize not just the value, but like, that is a portion of some total whole. So this is where a stacked bar chart works pretty well, I think. And you can make this relatively easy, like at least a stacked bar chart. You could probably add some extra here if you really wanted to emphasize something about it. But you can see a little bit is that it's relatively quick to like pull up like, oh, what portion of this section is taking up the whole bar chart, or so the whole bar, I should say. And what's great is that you can actually compare the two versus like this original, which is the same data from earlier. This right here, it's not easy to go from here and then look at this one and then look at this one and see how those change versus like I would argue, look at that stacked bar chart. I can very quickly compare the two. In fact, they're right next to each other. There's also a slip graph, which I honestly am not a huge fan of. I think it does add a little extra complexity for some people. But you can see a little bit of like how, for example, in this case, these different metrics, excited, kind of interested, bored, not great. You can see at least how it changes. So if you really want to emphasize the change and say, oh, look, more people are excited and kind of interested, but a lot less people are okay now. So this would be kind of a way to emphasize this. So I personally don't like this. I don't personally use this too often, but it can have its use cases. The last one, what was it? The other one I was going to say? No, oh, there's also something called a waffle chart. Does anyone know what a waffle chart is by chance? No, okay. So this is kind of the idea of a waffle chart. And I think this is kind of people who have to, have been doing pie charts their whole life and they're like, I need to get off pie charts. This is kind of like their transitional drug away from pie charts. I think they're pretty decent and for a lot of situations. They still have some issues with it, for example, you still have to kind of compare, but I think for the most part, seeing these values, they're really easy to compare with each other. I have seen things like this too. Oops, which one? Here we go. You can see this one right here where it's a portion of something. I think that's all right, but I think that still gets a little more difficult. I think a stacked bar chart in general is fine. And plus, stacked bar charts are pretty much supported across any visualization tool that you have. So versus waffle charts, you'd have to do something special with Matplotlib and Seaborn. Okay. Oh, I see there was some more chats and I realized I missed it. Oh, Safe, did you? Oh, you guys are sharing the links. All right, cool. What's this? Sorry, Safe had a Homer Simpson statistics. I couldn't see it exactly, but probably relevant from earlier, huh? Yeah, I think you're muted if you're talking.
Yeah, I think I shared a picture. I'll share it in the Slack, but yeah, it's something from that Homer said. I will yeah, I'll just do that now.
Okay, yeah, cool. But yeah, that's kind of all I had for the visualizations. Like I will say, like I didn't show like too much of the actual, how to say this, the like doing the actual coding stuff like that. But I think that's because I think the important part is to know what do you want from your visualization before you actually start just doing something. And for exploratory, you usually don't have to worry too much about like the exact values. Like, you have to worry about too much of like, if you really want to do a pie chart, I guess you could for exploratory. But I would argue that other things are useful. But you don't have to worry about too much about like data ink and stuff like that for your own exploratory visualizations, because it's really just for you to kind of explore. But for explanatory, I think a lot of these concepts are really important because you're communicating with someone else who isn't you. Okay, cool. All right, well, yeah. Any questions or anything you guys wanted to add to this? No? Pretty good. Okay, well, I'll stop the recording here now, unless, oh, did someone, no, okay. I'll stop the recording here.